So hello everyone, today we'll be solving DP problems from HackerRank. So the first problem is the coin change problem. So let me write the C++ boilerplate first. Yeah. So what does the input format say? The input format says that you will be given an integer n and an integer m, and m is the size of a vector named coins. Alright, we'll be writing our logic in a function named solve. I will be passing coins n and m here. Alright. Now let's write the naive recursion solution first. It would be having the same arguments with some extra arguments. So let's take two extra parameters, I and which denotes the current index, and amount, which denotes the current amount we are holding. Currently we are holding the amount 0. I would write it later. So what's the structure of recursion? The structure of recursion is pruning. Base case, condition check, which is optional. Like if the question specifically needs something that has to be checked, then we will do it. Otherwise, no. Recursive call, or it could be multiple calls. So let's start writing the pruning. What does pruning mean? Pruning is basically like when your code fails, like when it gives a out of bounds or something like that. So if my index exceeds the value m, which is the size of the array, it would go out of bounds. Greater than or even equal to m, it would go out of bounds. Index in the sense I, sorry, I, if it goes out of bounds, then my code would fail. Otherwise, if my current amount that I'm holding is greater than my required amount, see, you cannot make a 5 rupee out of 10 rupee notes, right? If my current amount itself is 10, you cannot make 5 out of it using any denominations. In that case, I would return 0. Alright. Coming to the base case. Base case is the case where you succeed. If my amount equal to n, that's the required criteria for saying that you have found a way. You have found one way. In that case, I would return 1, which means one way. Condition check, as I said, it's optional. If the question mentions anything in specific, you need to implement a condition check, but question doesn't say anything like that, so you can directly go for recursive calls. See, let's take two possibilities. It comes under inclusion exclusion thing. So if what would happen if I include it, if I pick it, it would be going for recursive call for coins, and int n, this wouldn't change, m wouldn't change, index also wouldn't change. Amount would become, since I have picked a new value, amount would become amount plus coins of index. What if I don't pick? What if I drop? If I drop, coins wouldn't change, the coins array wouldn't change, n wouldn't change, m wouldn't change. Since I'm skipping that index, it would become I plus 1. And amount won't change. Amount won't change. How to get total number of ways? Total number of ways. How to get this? The number of ways to make that particular amount using the pick. When I pick, can I make that amount? If yes, how many ways? It would be pick. The variable pick would be storing the number of ways that I would be getting if I pick it. If I pick that current index coin, and similarly drop. Pick plus drop would give me the total number of ways. Now, okay. So before this, I tried to submit blank code to check if the compiler and the network is working. And here I would return solve of coins nm. Index, where should I start from? I should start from 0, and amount I should start from 0. I would return this. So let's see if this, sorry, it's not solve, it should be REC, recursive function. So let's see if this thing works. Hopefully it should work. Yeah, and it worked. Now how to convert this to DP? How to convert this to DP? Let's take a DP array. So what would be the dimensions of the DP array? Here you can see the two variables are varying. One is index, which is becoming in some recursive calls, it's becoming index plus 1, and amount, which is varying. It in some recursive calls, it's becoming amount plus coins of 5. So two state variables exist. So you need to take two-dimensional DP array, 2D DP array. Okay. And what would be the size? It should be n plus 1. I mean vector int n plus 1, and initialize with -1. Why -1? -1 is an impossible value. You cannot never ever have -1 base. -1 base is something that doesn't exist. So it would be helpful for checking if that particular cell is previously visited or not previously. If it's previously visited, it won't have -1. It would have something else. It would have 0, 1, or some other value. If it's not visited, it would have a -1, which is impossible. Our recursive function never returns -1. It would always return some value greater than or equal to 0. So yeah, let's pass this to our recursive function. And coming back to the recursive function, we will be passing this by reference. Make sure you pass it by reference. Why? Since you're modifying it, it's very basic programming thing. Always do pass by reference, especially for something you're modifying. So how to simply make it a DP solution? Firstly, let me take care of this error squiggles. Yeah. So the DP principle is pretty simple. Before computing, please have a check. Please have a check that have you computed it previously. How to check if it's computed previously or not? So if it's previously computed, that means DP of I and amount will not be equal to -1, right? If it's previously computed, it would have some value greater than or equal to 0. Then it won't be -1. In that case, it's previously computed. Since it's previously computed, I would return it directly. Return DP of I and amount. Awesome. Next. This if statement is useless until you keep updating the DP array. If you never update the DP array, it's simply again the recursive solution with an extra if statement that never works. So where to update it before returning? Please store it. Please store it such that the DP array gets updated. So once again, this thing also should work. Since the logic is absolutely right, this thing also should work. Yeah, and this thing actually worked. Now let's go for the tabulation solution. So let's comment this. All right. Now coming to the tabulation solution. How would you make it a tabulation solution? So while making tabulation solution, since you're never calling this thing again, it's just a piece of text now. It's no more a function. Like it's a function, but you're not using it. So there's always an amount way to make an amount 0. We don't need that -1 thing because in tabulation we will be starting only from the valid ranges, so we don't need pruning as well as the -1 thing. We are never storing the impossible values. We are always storing the valid values from the valid ranges. Since it's iteration, you know a range where you should start from. So how to convert the same recursive solution into the tabulation one? I should start from see, recursion is the like it backtracks, right? So the last index would be uh, done first and then the first index. So while making the tabulation solution, there are two ways of making it. We will discuss both the ways. We'll discuss both the ways. One is finding the inverse function, inverse recurrence relation, and one is writing the loops in reverse. Both things actually work. You can do any of them. So to start with, index equal to 0. Index is starting from 0. See, here in the recurrence relation, when you're calling the recursive function, you have also provided the argument 0. So you should start it from 0, similar to the recursion logic. And I plus plus. I is getting incremented here, right? So I plus plus. Now, writing the loop in reverse, what does this mean? What does it mean? What it means is you are adding amount plus coins of I. You need to write this loop in reverse. So it also depends on which parameter you are taking first in the DP array. If you are making DP array of size n plus 1 and vector int m comma 0, if you are doing that, then you should do it in the reverse way. But for now, yeah. So I know something. From the base case, I have written the recursive function. If my amount equal to n, if my amount equal to n, it's always one way. If my amount equal to n, sorry, n, there's always a way. This is something I know. So here it doesn't matter if you write from 0 to m or m to 0, whatever you like, you can write the loop, because this is not a transition, it's initialization. So this step is initialization. Here it doesn't matter what you write. You're basically initializing something. You can do it from reverse or as you wish, basically. Okay. Now, int I equal to, since recursion backtracks, we would be writing m minus 1, I greater than or equal to 0, I minus minus. Similarly for amount, int amount equal to, sorry, not equal to n minus 1, amount greater than or equal to 0. Why n minus 1? Why not n? N is already, we are already done with n. We need not handle it separately. And amount minus minus. So why another reason why we need to take it in the reverse order? You have defined n. You have defined n. What is the adjacent row, adjacent column to it? N minus 1, right? Adjacent column. N minus 1. Is that right? So from adjacent column, you can form a transition. If you start from 0 or something, it would be like a gap. 0, 1, 2, say your n is 5, 5 is initialized. 0 to 5, you cannot make a transition. There are states in between. So if you are starting from 0, it's not gonna work. But there are other ways. You can invert the function. You can find the inverse of this recurrence relation. Then you can do from 0, the exact same logic. So for now, let's write the loops in reverse. We'll also discuss how to invert that function to actually write the logic from 0. So I would take two variables, in pick equal to 0 and drop equal to 0. And same thing what I wrote for pick here for the recurrence relation, I would write the same thing. If my what can I say? In pick, I need to compute amount plus coins of I. Amount plus coins of I. So if my amount plus coins of, sorry, amount plus coins of I is less than or equal to n, is that it? Is less than or equal to amount, yeah, is less than or equal to the required amount n. In that case, I can do dp of I amount equal to dp of, sorry, not this one, pick equal to dp of I amount plus coins of I. The same thing I wrote here, the same thing. Is it the same thing? Yeah, amount plus, see, these two are the variables. You always need to write them in the DP, the DP data structure. DP of I, amount plus coins of I. Did I write the same? DP of I, amount plus coins of I. Yeah, I did write the same. Next thing, If next, what's the check? Here amount is being static, I plus 1. If my I plus 1 is less than or equal to, what's the range of, what's the max range it could go? My I plus 1 is less than m. In that case, my drop would be equal to dp of I, sorry, dp of I plus 1, and amount remains static, right? Amount remains static. Amount doesn't change. Since I'm dropping, I'm adding nothing. Same recursive logic implemented in the form of an iteration. Pick and drop are never used. Pick is set but unused variable. Why is it showing this? I don't know. Some random thing. Okay, we haven't called it in this block. We have called it in if block. So yeah, seal and do show these kind of things. So after this if statements, our DPRA filling is over. Filling is over. Completely over. Now, after this, the same thing I have done in the recursion. DP of I and amount equal to pick plus drop. Is that it? Yes, it is. After this, what's the last computed state? Like in the what am I returning here? What am I returning here? I'm returning uh, a particular instance of recursion where index equal to 0, amount equal to 0. Same thing I would denote it as, dp of return dp of 0 comma 0. All right. So this thing should work. Once again, let's check the logic and submit it. Perfect. Logic looks absolutely right. Let's run this code. And yeah, this thing passed. Hopefully after submitting also it should pass all the test cases. No, it didn't. What could be the potential issue? One could be that it for sure needs some 1D DP optimization. That's one thing. Otherwise, I need to replace all the ints with long. Uh, Probably a reason could be integer overflow. The most possible reason, I guess, it's integer overflow. So I would correct it by doing Control F, and I would find int. So there are some instances of int. I would replace it with long. Okay, replace all. Everything is changed to long. And long main is something that's not correct. This should be int main only. Yeah. Once again this passed. Once again let's submit. This time it passed every single test case. Yeah, it passed every single test case, and we are done with the first problem. That was quite good. In the next video, probably we'll discuss the other way, that's inverting the function, like writing different function for both the things. Even this thing works. The best thing is reversing the loops. Since you know recursion backtracks, you can just reverse the loops. This is also a good way of solving this problem. So thank you everyone. Stay tuned for the next video. Bye.